Topic 1, Lesson 5, Light, pages 44 to 53 in your textbook. So as always, we're going to start with the connect it. So shadows are made by different objects in the picture. You need to label two shadows with the names of the objects that made them. So here we have the window frame or the person. You could also do the rag. That would be another thing. All of those things are seen in the shadows. Shadows, figure 1, you can see shadows of both the person and the window frame. There is no shadow of the panes of glass in the window because light passes through them. So, to answer our question, why do some objects make shadows while others do not? Opaque objects make shadows because light does not pass through them. The shadow is in the area where light would have been had it passed through the object. Objects you can see through do not block the light, so there's no shadow. Alright, so continuing on, light, color, and objects. Light usually refers to visible light that determines what we see and how it appears. Materials can be classified by how much light transmits through them. Transparent means that it transmits most of the light that strikes it. An example is window or plastic wrap. Translucent means that it scatters the light that passes through it. Examples are wax paper, Jello. Opaque, reflects or absorbs all of the light that strikes it. Example, a book, a marshmallow, a hippopotamus, anything you can't see through. And these are all excellent examples up above and pictures to express that. The color of objects. So white light is a mixture of all the colors of the rainbow. Light that shines on an object can be reflected or absorbed. Opaque objects are the color of the light that the object reflects. It absorbs all other colors. Brown is a combination of red and green, so it reflects both red and green and absorbs all the others. Black means that it absorbed all colors of light. White means that color is a reflection of all colors. A transparent or translucent object is the color of the light that passes through it. Example, a drinking glass is green because only green light passes through it. Light and color. So when light shines on an object, some wavelengths of light are reflected and some are absorbed. Circle the answers that correctly complete the sentences. So the color of an opaque object is the color of light it absorbs or reflects. And the answer is reflects. If the object absorbs or reflects all the light, the object appears black. The answer is absorbs. And that's demonstrated in this image down here of the soccer balls. So question, why does snow appear white? And the answer is that it reflects all colors of light. Color filters. So colored filters, it's a tinted piece of glass or plastic that only transmits part of white light that is the same color as the filter. An example, a red filter only transmits red light, so any object that is red looks red. All other objects appear black or gray. Color filters are used in photography and movies to create moods or special effects. So figure 3, photography and color filters. Color filters can be used in photography to bring out certain colors or create dramatic moods. For each of the inset images, write the color of the filter that produced the altered images. So in the first one we see red, therefore it is a red filter. In the bottom one we see green, therefore it is a green filter. Alright, reflecting light. Regular reflection. Parallel rays of light bounce off a smooth surface, creating a clear image. An example being a mirror. Diffuse reflection is when parallel rays hit an uneven surface and don't bounce off in the same direction, creating a distorted image or no image at all. Regular and diffuse reflection, light reflects off the surface of water. For each type of reflection, circle the terms that correctly complete the sentence. You can or cannot see an image in the still water because the light undergoes regular or diffuse reflection. And we can see an image in the still water because the light undergoes regular reflection. You can or cannot see an image in the choppy water because the light undergoes regular or diffuse reflection. And that is cannot because it is diffuse. Mirror images. The most common way to get a clear image using reflecting light is with a mirror. There are 3 different types of mirrors: plane, convex, and concave, based on the shape of the mirror surface. A plane mirror is a flat mirror that produces a virtual image, forms where light seems to come from. The image looks upright and the same size, just reverses the right and left sides. So a plane mirror. In this virtual image, the reflected light rays appear to come from behind the mirror where the image forms. The distance from the image to the mirror is the same as the distance from the object to the mirror. Convex mirrors. Convex mirror is like the outside of a metal bowl because it is a surface that curves outward. The image looks smaller than in a plane mirror. A convex mirror image. Most rear view mirrors are convex. Light rays bend when they hit the surface of the mirror in such a way that the object appears smaller than it is. And that's why if you're in a car, on the rear view mirrors, it does say objects in mirror may be closer than they appear. An optical axis divides the mirror in half, the center of the lens. The focal point is the location at which rays parallel to the optical axis reflect and meet. The light reflects off the curved surface so that the image appears to come from a focal point behind the mirror, making the objects appear smaller. Concave mirrors. Concave mirror curves inward like the inside of a metal bowl. The focal point is on the reflecting side of the mirror. The virtual image. The object is located between the focal point and the mirror. Image is not inverted and is larger than the actual image. A real image is one in which an object is located further away from the mirror than the focal point and the image is inverted. So, mirror images. The images formed by mirrors depend upon the shape of the mirror. Examine the diagram and then identify the type of image on each example. So at the top, the object is located further from the mirror than the focal point is. It forms a real image. And in the second, the object is located between the mirror and the focal point. It forms a virtual image. Reading check. If a mirror image is inverted, what type of image is it? And that is a real image. Model it. Fun with mirrors. In a fun house, mirrors are often used to change the appearance of objects. Suppose you want to use a mirror to make a door look smaller and rounder. In the space below, draw the mirror and the door along with the focal point. Label the mirror with the type of mirror it is. So, your model should include a convex mirror and a door in front of it. The door's reflection in the mirror should appear smaller than the door itself. The mirror should be labeled convex. Convex lenses. So light can reflect like with a mirror, or it can refract or bend. A lens is a curved piece of transparent material that refracts light. An example is a telescope, microscope, eyeglasses. Convex lenses are thicker in the middle and thinner at the edges. As light passes through it, it refracts toward the center of the lens, or the optical axis. The more curved the lens, the more the light refracts. Again, a virtual image is an object. An object is between the lens and focal point, and the image looks larger than it is. An example, magnifying glass. And the real image, the object is further away from the lens than the focal point, and the image can be larger, smaller, or the same size as the object. So, convex lenses. A convex lens can form a real or a virtual image based on the locations of the objects and the focal points. Correctly label one image as real and the other image as virtual. So, The first one is going to be virtual, and the second is real. Concave lenses. Concave lenses, they are thinner at the center and thicker at the edges. When light travels through the lens, the rays are bent away from the optical axis, or center of the lens, so the rays never meet. Concave lenses form only virtual images that are upright and smaller than the object. Concave lenses, figure 9. When looking through a concave lens, a virtual image forms which is always smaller than the object itself. After examining the diagram, circle the photo in which the image is formed by using the concave lens. And that, of course, is going to be this one because the text appears smaller. Reading check. In what ways is a convex lens like a concave mirror? And what ways are they different? So both concave mirrors and convex lenses focus light, and the type of image formed depends on the location of the object compared to the location of the focal point. A mirror reflects light, while a lens refracts it. And that finishes that, and now it's time for a lesson check. So what kind of material transmits some light, making objects behind it appear blurry? And that's translucent materials, such as waxed paper. 2. A bird runs into the window of a building because it sees the reflection of the sky in the window. The sky does not appear distorted in this window. What type of mirror or lens is the window acting as? Explain your answer. It is like a plane mirror because light rays are reflected in the same direction they strike the window. 3. When a person is nearsighted, an eyeglass lens is needed to bend light entering the eye away from the optical axis. What type of lens will do this? A concave lens? 4. Why might some rearview mirrors in a car state objects are closer than they appear? Convex mirrors are used, and because the image is smaller, the objects seem further away. Suppose a movie director is filming on a set that should look like a hot desert. He wants the scene to appear warmer, such that the red and yellow tones are the most apparent. What color filter should he use? What color will the blue sky appear when he uses those filters, and why? So he should use red and yellow filters, since they will transmit red and yellow light, which will make the scene appear warmer. The blue sky will appear black, since it does not reflect red or yellow light. And that finishes this section, as well as this topic.